supposed to be a crop walk. This was our field replacement for our field tour this year that didn't turn out too well since none of our crops turned out too well. We actually lost the majority of our trial out here at our Medicine Hat location. I have to give a special thanks out to Laverne. Is Laverne here today? So Laverne and family, they actually used their semi and hauled water out to some of our critical trials just so that we'd actually have something in place for next year. So as a thank you to all of our sponsors that didn't pull their money away when we canceled the crop walk and allowed us to put on a makeup event. So that's what today is about, and it works out great. I don't think we've actually had this many people out to one of our Medicine Hat tours. So thanks so much for coming and for the support. We have a pretty fun day, I think, planned. It's a short one, so you can handle it. And we've got Dr. Bob Blackshaw starting this morning with a very timely talk on kochia resistance, and Dr. Jamie Larson as well from Ag Canada, myself, and Brent Smith talking about drought management in pastures. And then the afternoon, what everyone is really interested in is sort of the long-term weather forecast, which you learn. But first I would like to invite Miss Ivanex up from Drew Barter's office to sort of send greetings from his office. They're sitting in the legislature right now, so if you wouldn't mind coming up and saying hi to everyone.
Good morning, everyone. Drew would truly like to be here himself, but as Ken mentioned, he is sitting in the Legislative Assembly today. And so it is my pleasure to bring greetings on behalf of Drew Barnes MLA for Cypress Medicine Hat to your workshop. Farming Smarter's regionally focused, producer-oriented, collaborative approach is much needed and much appreciated in the agricultural marketplace today. Your goal of increasing producer profitability by delivering science-based, unbiased information is commendable. On behalf of Drew Barnes and the constituents of Cypress Medicine Hat, I would like to take this opportunity to extend my sincerest gratitude for all the efforts that you have made and continue to make, which positively impact the lives around us. Thank you.
I never did ask you, Gary, but would you like to come and send greetings as well? The county, sure, come on up. The county of Cypress has really been pivotal in allowing us to do the good work out in this area, which is kind of a special area too. So this has been a co-hosted event with the county of Cypress, and Jason Storch really appreciate the support that we get from this county to touch on information in a very unique area. Sorry, Gary, going on the spot, but I figured you could handle it.
Yeah. Well, on behalf of Cypress County's Agricultural Service Board and the producers in Cypress County, I'd like to thank Ken for his efforts and for the people he has arranged to speak here today, and I hope you all enjoy.
So without further ado, I'd like to ask Dr. Bob Blackshaw to come to the podium or stand on the floor, whatever makes the most sense with this odd arrangements of computers.
Okay.
Thanks.
Well, thanks, Ken. Good morning, everyone. So I'm going to talk, obviously, a little bit about glyphosate-resistant kochia and what we've been up to the last couple of years. So I've spoken on this at Agronomy Update a couple of times, and perhaps you've heard some of this. So maybe there'll be a little bit of repeat information, but hopefully there'll be some new information for you as well. And then we'll try and have some time for questions at the end. So we'll see how we go. So first of all, I just want to acknowledge my co-authors. You probably know some of them. Linda Hall is a professor at the University of Alberta. Hugh Becky is a weed scientist with Agriculture Canada in Saskatoon, and he's really our foremost expert in weed resistance in Western Canada. And Alicia Torbiak is a graduate student at the University of Alberta that we have working on this project. So this is just a map of kochia in North America, and excuse me for turning around a little bit and looking at it, but so the darker color means that the greater distribution and densities of kochia. So you can, first of all, you can see it's pretty widespread throughout the whole Great Plains of North America, right from Texas up into our location here. And you can see the darker color there is in those states and comes right up into southern Alberta and southern Saskatchewan. And just to sort of make note that glyphosate-resistant kochia was first found in Kansas in 2007, and now has been documented in many of those other states that you see on the map. Our first experience was in the summer of, it was actually August, I think, of 2011. I received a phone call from a grower that said, he had sprayed glyphosate on his fallow fields and was having a problem, and some of his neighbors were having a similar problem, and asked me to come out and have a look. So I, when we talked on the phone and the way he described what it was, I thought, yeah, okay, this is probably real, because I was aware of what had happened in Kansas and what their story was a bit. So I called up Hugh Becky in Saskatoon, and we went out together and looked at these fields. And so the obvious thing we saw is these kochia trails, which probably you guys are now familiar with or were familiar with, but you should be very familiar with them now. So that's a plant that breaks off, blows across the field, and it's dropping seed as it blows across. And so that kochia trail there, that's probably, that's one plant. And it's dropped seed from the previous year, and that seed germinates, and we spray with glyphosate, and it survives. And so when we went out and saw that, I guess we knew it was bad news. But science is science. You have to go through the whole documentation. So we collected plants from 3 different farmers and brought those plants back into the greenhouse, and we let them mature seed in the greenhouse because we wanted the grower to go ahead and control those plants. So we let them grow in the greenhouse, we let them produce seed, and then we planted them in the greenhouse, and we did all of our testing under controlled conditions. And you'll see the 2 green lines are the susceptible populations, and they're controlled at relatively low rates of glyphosate on the diagram here. And then you'll see some blue and red lines over there that are indicating you need a lot higher rate of glyphosate to control them. So our friends in Kansas sent us 3 populations because they had more experience than we did. They were ahead of the game for 2 or 3 years, and so we wanted to sort of compare our populations to theirs. And the first thing you can see is there's quite a bit of overlap there. So immediately it told us that our populations in Alberta were responding in a similar manner to those in Kansas. And when we look on the right-hand column, this RF column, that tells us the resistance factor. So those populations required 4 to 6 times more glyphosate to get equivalent level of control compared to the susceptible populations. So we did that twice in the greenhouse. We had to be pretty sure of our results, and then we went and released that information to the media, and that story sort of went from there. Now, I did one more experiment in the summer of 2012, okay, in the field, because the field is a real world. Is it the same in the field as it was in the greenhouse? And it was very similar. We ended up with a resistance level of 6.2. So after that, then we want to know how widespread the problem was. Was it restricted to a small area in Warner County, or was it more widespread out there already? And so Linda Hall coordinated this study in the fall of 2012, and this was a random survey, just went out and randomly selected plants and tested them. So you can see certainly we had more populations in Warner, but you'll see there was already a big group up in Vulcan County at that time, and one in Tabor. So that was just a random survey. Nobody telling us that there was a problem. We just went out and collected those plants. Then this story is actually people that brought plants to us and said, okay, I'm pretty sure I have a problem. Will you test that to see whether it is resistant? And so you see southern Alberta where we're located, but I think the important thing, or the interesting thing for us, is there was already a lot of populations in Saskatchewan that were resistant to glyphosate. So the story was there. I just want to back up. That was 2011. So certainly we had glyphosate-resistant kochia in 2010. We had it in 2009, probably had it in 2008, but no one was really telling us about it or raising the issue. So I just want to sort of stress again, when you see a potential problem, don't be embarrassed by it. Tell somebody about it, and then researchers like myself can get on the story a little bit faster. So 2013, Hugh Becky did a survey, a random survey in Saskatchewan and in Manitoba. So this is what he found. Saskatchewan, most of them are between Swift Current and Kindersley, similar to that previous map I showed you, but there was a population outlook and one at Moose Jaw. And then when he went to Manitoba, he found a couple south of Winnipeg. So not nearly as widespread in Manitoba, but there were a couple populations there. So a quick summary, you can read it for yourself. So we now have it in the 3 provinces. I think it's noteworthy to know that most of these populations were selected for on chem fallow. This is not Roundup Ready crops that you'll read about in the US, were selected for by Roundup Ready corn or Roundup Ready soybean. Most of these fields had never grown a Roundup Ready crop. So this was selected for fallow, where they might have used glyphosate plus a Banvol or glyphosate plus something else. They had gone to straight glyphosate for several years in a row and put incredible selection pressure on for resistance. And the same story is happening in the oil well sites. They also used to use a residual herbicide or tank mix glyphosate with something, and many of those guys have gone to straight glyphosate on their oil well sites. And so several of those submitted samples in the first year that came to me were from oil sites. So the resistance mechanism, most of this work is coming out of Kansas and Colorado. But we submitted some of our populations down there to compare with theirs. And most of our resistance that we have in our other weed species is what we call an altered target site. So the enzyme that the herbicide binds to inhibit that enzyme has changed its configuration, and the herbicide no longer binds to it, and we have resistance. That's probably number 1 around the world. And the number 2 mechanism is we have enhanced metabolism. So the herbicide just breaks down so quickly in the plant that it's not able to do its killing action in the plant. So this is another mechanism, a gene amplification. And what we have here is we have more copies of the gene that codes for that enzyme. And what we're doing is just sort of flooding the plant with more enzyme. So we cannot get enough of the herbicide to get to all of the enzyme in the plant. And sometimes it's the enzyme only in the growing point of the plant. So we can't get enough there quickly enough that the plant survives, and that's a resistance mechanism. So that's a fairly rare resistance mechanism, but it is also been found in at least 2 other weeds that are resistant to glyphosate. So now I'm going to get into some of our herbicide work. So one of the things we wanted to do in the early stages was to provide sort of quick answers on what herbicides you could be using if you couldn't use glyphosate, or to use in combination with glyphosate. So we did experiments in fallow, we have some in wheat, we did field peas, we did canola, and so I'll go through some of that data and show you some of our results. So the first one here is in a fallow situation, a non-crop situation, and I just want to draw your attention to the bottom. So all these herbicides were mixed with glyphosate. So the whole thing is here, you're going to still be using glyphosate, most likely. So what can you add to the tank with glyphosate that is going to control kochia? And you can see the weed stages down here. Kochia was larger. We did that deliberately because often you have staggered emergence in your fallow fields, or you're busy doing other things, and sometimes not all the treatments get down. So the plants, that's 6-inch tall kochia, fairly big diameter, but we wanted to make it a tough test, and so we did that deliberately. So you'll see that some control is maybe a little worse than what you might expect, but I think in some cases this is the real world as well. So we'll just go through some of these. Fluthiacet is an unregistered compound. So I guess the other thing in all of our studies is we want to look at existing compounds out there, but we did a lot of work with non-registered herbicides that the companies think could have a fit in our marketplace the next 3 years. So we're helping them determine whether they want to advance that and move it forward to registration. So I think some of those things, they won't be registered for another 2, 3, 4 years, but we're sort of seeding the groundwork for some of that work. So fluthiacet, it does show some promise. You'll see in a fallow situation, non-crop situation, maybe not enough on its own. 2,4-D ester, I just want to highlight, I said, you maybe heard me say this before, 2,4-D does not control kochia, so probably contrary to what many of you think, but you will only get suppression with 2,4-D. Optica Trio was pretty consistent. Then we get into dicamba or Banvol is also pretty consistent treatments, although you maybe need to go to higher rates than what you're used to using. And then Distinct, which is a compound from BSF, which includes dicamba, is also pretty good treatment. Then we get into AIM. So all of these ones then become group 14 herbicides. So that's sort of nice because there's another mode of action. AIM, Volterra, Heat, Authority, they're all group 14s. And you see that they all give pretty good control into that situation as well in a fallow. And then our results in 2015, somewhat similar. I guess I would say overall the control levels are a little lower than what I just finished showing you. And what we had happen in 2015 is we had drier conditions and we had warmer conditions. We almost too hot of conditions. We were up in the high 20s to 30 sometimes when we sprayed, and part of it was just drier conditions, so the plant kochia wasn't as actively growing, and then often the herbicides don't work quite so well. And then if we go look at heat, that 50-gram rate of heat, we would get residual control if we had good soil moisture, but we didn't have sufficient rainfall to have that, so that treatment was not as good as the year before. And even Authority, which requires some soil moisture to really be good, was not as good as the previous year. So. Somebody's got some music playing. So now, now I'll just show you some photos of what they look like. So there's our untreated kochia here. This is in 2014. This is 2,4-D ester. So as I said, it's just a stunting action. It's more of a growth suppression. And if you think 2,4-D works, it's because it's always been included with something else. You probably mix it with dicamba, or you mix it with mecoprop, or you mix it with dichloropropyl, or some of those mixtures work, but 2,4-D by itself is not great. Here's dicamba, so that rate, just to translate that, so that's like a 4-ounce rate of dicamba. If you're mixing it in your wheat with something, you're probably using 110 to 140 to 150 or something. So that is a higher rate of dicamba right there, but it is a good treatment. And here's Distinct, also good treatment. Here's Heat at 18 grams, a pretty good treatment. So we've had a few escapes there, or we've had a few plants germinate after we sprayed. Not a bad treatment, but you can see it's, you're going to have to come back and spray again there pretty soon. And here's Heat at actually 50 grams in that first year, where we actually are getting some residual control with that high rate of heat if you wanted to go that way. 2015, untreated. There we go to 2,4-D. It was actually quite sad. Here's dicamba. Again, it's looking pretty good. Here's the high rate of dicamba. Distinct. Optica Trio was one of those sort of phenoxy ones that was probably the best treatment, and it's the mecoprop component of Optica Trio that's actually doing the best job in there. So this is MCPA, dichloropropyl, and mecoprop, and it's actually the mecoprop part that's doing the lion's share of the work in that treatment. And then here's AIM and Authority, which is also, again, pretty good, I guess. So we'll go into some of the wheat data. So these are in-crop treatments in wheat. And just sort of go down, if we look at the first 4 or 5 treatments, or dicamba, some of our standbys, our dicamba 2,4-D, bromoxynil, esterprop, target, all of those are fairly marginal treatments. They're a little better at Colehurst. The weed kochia was a little bit smaller sometimes, but they're sort of borderline treatments. We get into better treatments when we go to a high rate of dival. Optica Trio, like in fallow, was also pretty good. And then probably the better treatments are anything containing fluroxypyr. So that's your Prestige, your Attain, your Pulsar. Those compounds are all good. So fluroxypyr is a dynamite compound on kochia. So anything that contains that is going to be some of your better treatments. And then you go down to Enforcer D compounds from New Farm. And FMC, and looking pretty good. And then, and I guess another nice, I don't know, it was a surprise to me, maybe shouldn't have been a surprise, but Infinity is pretty good and pretty consistent, and so that's good news because that's another mode of action again as well. So we have a group 6 and a group 27 mode of action in Infinity. So that's potentially something to think about in terms of rotating herbicides. And then Authority is not registered in wheat. But it looks like the company is interested in moving ahead in terms of a registration in wheat as well. So So right now you're going to be using that in your peas or perhaps crops like that, but it maybe has potential in wheat. And as I say, the company is interested in that. And so then 2015 data, you'll see now we have Lethbridge, but instead of Colehurst, we did the data in Edmonton in 2015. And I think a pretty similar story to what I showed you. Phylloxera probably coming out some of the better ones. Infinity still looks pretty good. We went to straight Banville by itself, and it's decent, but probably you're still going to want to be mixing with something. And then Authority continued to look good in Lethbridge. Authority with a higher organic matter in Edmonton, and the drier conditions that they had this year was not as good. And then we have this Fluthiazet plus bromoxynil, actually like pretty good at my location, and was a failure in Edmonton. So there is potential for that new compound in the future. We look at peas. So we start off with a lot of treatments that we put down in the fall. We have Edge, Curb, Peroxysulfone, Volterra, and then we had combinations of those. And the first thing that you can sort of see is that really none of them worked very well. And Edge, I don't know, I guess I thought from my experiences 20 years ago that we would have got, I don't know, 70, 75% control, but maybe that's just a population thing. We had dense infestations of kochia, and so we tended just to get those numbers, whether it was in canola or in peas, we just tended to sort of get 50 or 60% control with the Edge treatment, but it could still be a good beginning in your program to use Edge, and then you're going to follow it up with another compound. That could be a really good strategy. Peroxysulfone is a new compound that you may or not be familiar with. It's called Sakura in Australia, been registered there for 3 or 4 years. It will be called Zidua in North America, and it has some potential, and certainly when we looked at Edge and peroxysulfone together, they didn't look too bad. So.
Was the Edge incorporated, or was it
No,
surface supplied?
it was granular surface supplied.
Okay, thank you.
And so if you incorporate it, you might get a little bit better. But I use this as a standard treatment in my research plots. And when we look at, if it's a green fox or a wild oat, we often get 95% control with that exact same application method. So we put it down late fall, rely on the snow melt and everything else, and it can work quite well. But it could be a little bit better with some incorporation. And then, so you get down to some better treatments. I guess AIM and Authority here is one of the better ones. Authority, as I mentioned before, that sulfentrazone is probably is a dynamite compound on kochia, so you want to think about using it where you can. And Viper still worked pretty well for us, and so that was actually a bit of a surprise. So Viper is Basagran and a Mazamox, right? So most of this kochia is group 2 resistant, so it's one of those things where we wouldn't always expect a Mazamox to sort of work, being a group 2 compound, but it still seems to be giving some control, and the mixtures together work pretty well. So the Viper treatment was pretty good. And then here's that Fluthiazet compound that I showed you earlier with some crop competition. Actually looked not too bad, and probably will end up being registered in the future in one form or another. And then so similar results, I think, in 2015. Again, as you look at AIM and Authority, really good here. The Authority, I already sort of mentioned that. It's very specific on organic matter, so if you have very high organic matter, Edmonton, they were at 7-8% organic matter. So it just binds to the soil particles and it's not available to be picked up by the plant, so is not as active. But those are some pretty good choices. We looked at metribuzin by itself. I was asked to include that. You need to go to high rates of Sencor, and then at that high rate, we actually had quite a bit of injury in peas. We had about 20% injury in peas. So, by itself, sort of borderline, and then Flomaxis and Volterra at the bottom, I think you probably just need to go to a higher rate. And then this is some of our canola work. So, obviously in Roundup-ready canola, glyphosate-resistant kochia is going to be a challenge. So Roundup's not going to work. And in Clearfield canola, all of our kochia is group 2 resistant. So it's also going to be a challenge. So now if you remember, I just finished saying imazamox, which is one of the active components in Clearfield, still gave us some control. So maybe you get some activity there. But so we said, well, okay, we'll go look at a Liberty Link because we probably have the better options there or more options there. So we deliberately chose Liberty Link. And then we really wanted to know how good Liberty was. So Liberty should be good, but we weren't too sure exactly. It's strictly contact action. There's no residual control. Liberty likes it to be sort of humid, likes it to be warm to get good control. We know that it doesn't work well enough on wild oats. And so I wasn't really that confident that how good Liberty would be. But it ended up being pretty good. You can see the numbers here. The 3 bottom treatments were all pretty good. And then I don't know what else to highlight. I guess just to highlight again that Edge by itself wasn't enough, but it could still be a good starting point if you went Edge plus something else, which if we went Edge plus AIM plus Liberty, then that was a really excellent treatment. And then show you a couple of treatments here that are non-registered. So Authority is not registered in canola, but Eric Johnson, who was working with Ag Canada and Scott at the time, suggested that he could get some tolerance in mustard species. He could get some tolerance in canola. So we took a flyer on this one and said, okay, can we go to low rates and still get some control and still get some crop tolerance? So the rate of Authority that's registered is 105 and 140. So we went to half rates and a quarter rates and see whether we can get something. So what it comes out of here is that we can still get kochia control, and that still seemed to come forward in 2015. But the other news is that we had probably unacceptable canola injury, or we had canola injury. So what is acceptable? How much will it grow out of it? So the 53-gram rate, probably a problem. Actually, the 27-gram rate, maybe not. Is there a fit or not? So I guess that's up for the companies to sort of sort through and forward.
27-gram rate, is that like the 40 acres of lots?
I don't know. I'm not bilingual enough to know that. But I told you the lowest rate is 105, and so whatever that translates into, that's a quarter rate of the 105. So if you know what that 105 rate does, then you can divide by 4. Okay, now I just want to talk about some other studies that we have on the go. So the most obvious and quick thing we wanted to do was to look at herbicides and try and provide some short-term answers to the glyphosate-resistant kochia is something you can use right away, and that's the number one thing probably as growers you want to know. But as researchers, we want to know a lot more than that. So we want to know more about the biology of kochia. We want to know, what other sort of non-chemical things can we do to control it, or we know, when's the timing we need to control it. What are some other things we need to know? And so the first thing is seed persistence. Certainly, I think there's a thought out there that canola doesn't persist very long in the soil, but we'd never done a study in Western Canada to really prove that. So what we did is we buried kochia in nylon packages in late October. So that's freshly harvested seed, and we buried at 3 depths, and then we extract that seed over different time periods. So April, June, August, and October in year 1, and we do it in year 2 again. We germinate those in a greenhouse or growth chamber, and we look at the viability of that seed over time. And we're doing it at Lethbridge, and we're doing it at Scott. And so we're only partway through these studies, but sort of the good news is that 90% of that kochia is going to do something in the first year. It's going to germinate and grow, or it's going to die. It's going to decay, it's going to rot, what's going to happen to it, but something is good. So you're probably only going to have 10% that's going to sort of carry over to year 2, and after 2 years, you probably are very close to 0. So that's sort of a good news. So it's not a persistence thing. Where wild oats, we may have them in the soil for 5 to 10 years. That's not going to be the story for kochia. So that's a good news story. Another thing we wanted to get a little bit more information on was dispersal. So kochia is a tumbleweed. I think you all know that. It's like a Russian thistle or other tumbleweed species out there. So its natural mechanism of dispersing seed is to The stem breaks off at ground level when it's mature, and then it blows in the wind. So that's the natural mechanism of seed dispersal, and you saw those kochia trails I showed you very early on. So what we want to do is learn a little bit more about that. So what we really want to know is, is kochia seed drop with distance and with time in the field. So we thought, well, we'll get a little bit fancy and have a little bit of fun with this. So we actually attached GPS collars on these kochia plants, and we go out on a windy day, and I go out with 3 of my students, and we let them go in the wind, and if it's a nice gentle wind, we walk behind them, and if we have a big wind, we run like hell, because those collars are worth $1,500 a piece, and we did not want to lose them. So I said to my students, I can replace you, but I can't replace the GPS collars. So we did this study, and it was sort of fun to do. The students loved it, and actually, I guess I sort of liked it. But so anyway, some good news here, I think, too, that about 50% of the seed drops within about 500 meters, half a kilometer, and probably 70 or 80% within 1 kilometer. So those tumbleweeds are, they might go 5, 10, 15 kilometers before they get stuck in a fence line or somewhere. But the good news is that a lot of that seed is going to drop into a relatively short period of time. So, most of it's probably going to drop on your field, on your farm. And so the idea of, some will blow onto your neighbor's property, or your neighbor will complain it's coming from you or whatever. There's probably a little bit of that, but maybe not as big an issue. And so that's just what we look, here's our tumbleweed. We've got them labeled. There's a little black line there. You can sort of see that's a GPS collar. These guys are all ready. We're just sort of waiting for the wind to come up. And like I say, so then we bring those plants back. We thrash them out. We know how much seed was on them to begin with from a harvest index. Harvest index of kochia is about 32%. So if you know what that means, that's the ratio of seed to the total plant. Harvest index of wheat is about 35%. Kochia is 35%. If you got a semi-dwarf wheat, it might be 40, 45%, 50%. So anyway, harvest index of kochia, that's something you learned today, for sure. 32%, so we know the weight before we start. We bring them back, we weigh, and we know how much seed we have at the end and how quickly it dropped. So another one we want to know is we had a question, well, if I'm doing kochia, if I have late germinating kochia in my fallow field that comes up in late July or August, or even later than that, or I have some kochia that's late germinating in my crop, how, do I have to control those before they set, a viable seed? And that's an answer we did not have. So, and I probably would have guessed, anything germinating after the middle of July probably isn't going to make it, because kochia is a pretty long season plant. I think you'll know yourself. It's one of the last ones to mature in the fall, stays green for a long time. So I would say I was proven wrong on that. So we have kochia emerging in early to mid-August in Edmonton, not just Lethbridge, in Edmonton, that produced a little bit of viable seed before killing fall frost. And so it wasn't a lot. I know one of those late plantings, we had about 70 seeds per plant, where something that germinated in the spring might be 25,000 seeds per plant. So it's a tiny plant, not much seed, but the seed was there and we germinated. It was viable seed and it germinated. So that sort of tells us that we cannot be too lax on this. If we have plants that are still germinating in that time, or you have plants that are sort of in your crop situation or field margins, edges of your fields and fence lines or whatever, and they can still produce viable seed. So I'm gonna wrap it up there. I just want to thank all the funding support that we've had for this study. So there's a long list here. The grower organizations have been great in supporting us in this research, and then four crop protection companies have added some funds to that as well. And so we're doing a lot of work here. We're getting a lot of new information, and we'll be continuing to sort of get the information out here. So I know I'm over time here, Ken. Do we have a couple minutes for questions? Yeah. Okay, so questions, anyone?
Okay, I'm asking one. Around this area, Medicine Hat, the drought and also sort of saline low spots tend to be havens for kochia development. But then the problem is when you go to control it, they're usually 6 feet tall and such. Of all of the options that you studied, what would you recommend farmers do to deal with that type of scenario?
Yeah, I think if they're really large, you need to think about, tillage or think about mowing or something like that, some type of non-chemical approach. So, and I think, I mean, we're all into no-till, and my whole career has been about no-till, but you're not going to ruin everything that you've done on your property by going out and cultivating 2 or 3 acres of an area, that's, especially if it's a saline area or something like that. So, and if, part of it is just about stopping seed set. So anything that can do that, if you do it early enough, then, mowing can be pretty effective, or especially if you mow a couple of times. And obviously you got to mow low enough, and it's got to be a repeat operation. But I would think of some type of it has to be a non-herbicide option, because no herbicide is going to do it at that stage. So you can go in and get a burn down with something like a Reglone, possibly, like something you would use as a desiccant. We'll sort of work on that. But even those, if they're fairly large, they will dry down the plant, but still there will be some viable seed produced. Okay, well, thanks very much for your attention, everybody.